This is group 2, and this is our second experiment in concrete mix design. As you can see, we have two samples. A pervious sample, which is rated at 3,000 psi, and a normal sample, which is rated at 4,000 psi. As part of our research process, we began to look online for different mixtures of pervious concrete. The one that we found that was most consistent and most valuable of a resource was a paper produced by Professor Hine on previous projects produced on campus. After we scrolled down the paper, we found different water content, cement content, aggregate mixtures for different types of pervious concrete for different projects done on campus. We took these numbers, scaled them down to our size of our samples, and then produced them on our spreadsheet. On our spreadsheet, we've taken the volume of our samples plus 20%, so we broke it down and did our calculations. We then found the conversion on another website. For our pervious sample, we used a water to cement ratio of 0.31. And then these water to content, cement content, coarse aggregate, and fine aggregate ratios, or percentages, we found and then converted to pounds for our project, with our total pounds for our pervious mixture at 18.52. We did the same with looking online at Pensacola testing laboratories. On here they have different products for concrete mix designs. They actually have a calculator where you can punch in the water to cement ratio, and it'll give you your water, your coarse aggregate, fine aggregate, and cement aggregate, all in pounds per yard cubed. We then took those and converted those to pounds as well, to find out exactly how much we needed for our mixture. As you can see from our conclusion, we had a 22.05 pound mixture.
It can get everywhere.
Let's cook some salmon, man. That shit smells gravy. Yeah, cook some salmon. Where's that? Where's that? That's all we do is stick stuff at the bottom. Just press it down. Just a gift, man. It's like, it's hard to live. I think we have achieved a little bit of veracity, guys. I don't know about you.
Wait, hold on. Okay.
Now we're going to start removing the formwork from our concrete mixtures. yourself out. Now that we've removed the formwork for both concrete mixtures, we'll take them and test them under a sink to see about their permeability. First, we're going to test the permeability of the 4,000 pound sink of concrete. And as you can see, none of the water gets through, it just runs off to the side. Now we're going to test the permeability with 3,000 psi pervious concrete. As you can see, the water is clearly going through.
We found out the pervious cement has more coarse aggregate in it than the regular cement, but it has less fine aggregate than the regular cement. But it also has more Portland cement included in it, the mixture.
We found that the porous sample of concrete weighed about 4 pounds less than the standard 4,000 psi concrete. This results from there being more voids in it, more air pockets for water to pass through and make it pervious.
In conclusion, these 3 points are the keys to pervious cement. More coarse aggregate of similar size, more Portland cement, and the absence of fine aggregate in the mixture.